Hi everyone. We are going to look at displacement, velocity, and acceleration of particles on a variable acceleration. That means when the acceleration of these particles varies, it's no longer constant as one previously. We have displacement here. You know what displacement of a particle is. Displacement, to start with, is a vector quantity, which means it has both direction and magnitude. We have velocity here. We mentioned velocity here. Velocity also has direction and magnitude. Therefore, it's also a vector quantity, as well as acceleration. These are all examples of vector quantities. What is velocity? Then, if you want to define it using displacement, if the displacement of a particle is expressed as a function of time, then its velocity is the rate of change of displacement. Likewise, if the velocity of a particle is expressed as a function of time, that you are given an equation in which the unknown in that equation is t, is time, then its acceleration is the rate of change of velocity. What does this mean to us? If you are given the displacement of a particle, say s, for example, and this s is expressed as a function of t, you can have s equals to 2t to the 4 minus 3t plus 2, for example. So this is the displacement of this particle is being expressed as a function of t. They will tell you what t is. And t is time in this case. So what is its velocity? You are given the displacement of this particle, for example. And how do you define its velocity? As the rate of change of the displacement will give you the velocity. What that means, if you now differentiate the s all by the t, the s dt, this will give you the velocity of this particle. The rate of change of the displacement of this particle gives you the velocity of this particle, v. It doesn't stop there. You now know this is velocity. So now, how do we define acceleration? Again, it's the rate of change of velocity gives you acceleration. Acceleration, I'll just abbreviate it by A, I, is the rate of change of velocity, that is the rate of change, the v, the t. That gives you acceleration of the particle. But from here, what did we say about v? V is the t, the s dt. Mind you, sometimes the displacement is given as x, not all the time is given as s, so it can also be x. But in most cases, the function is expressed in terms of t. So now, this is acceleration, the v dt. But we have v as the s dt. So it means if we substitute for v in this equation here, or in this function here, we now have d for this one, and v, what do we have for v? V is the s dt, and for this one, the v dt is still here, the v dt. This is acceleration. So it means when you differentiate the displacement twice, you get what? The acceleration of the particle. So which means this one, if we just distribute the t, you can get d is d square s dt by dt is dt squared. Mind you, you are multiplying these two. It's like 2 times 2 is 4. So it's 2 squared. That's what we have here. Here is only d that is being squared. So that this is how we define velocity and acceleration from the displacement of a particle when it is expressed as a function of t, or a function of time. Now, because these problems, variable acceleration, the displacement, the velocity, the acceleration, are expressed as a function of something. It could be time, it could be something else. Let's stick by the time. It means you're going to differentiate once or twice. So in that case, you need to understand the rules of differentiation. This is where calculus starts. It's part where differentiation starts. We don't say calculus, but calculus starts from limits of functions, from limits. So now, the rules of differentiation say you have the constant rule. Constant rule. You have the power rule. You have the product rule. You have quotient rule. You have constant rule, power rule, product rule, quotient rule. You have a fifth one. We might not need it here. Let's stick with these three. These are what we are going to use. Constant rule, power rule, and product rule. Constant rule. If you are given this function, d dt, and it's a constant here. This is a constant, it means it's just a number you are given. 5, 10, 15, 20, 1, 2, 3. So, when you differentiate that number, you get 0. Here, you are given a function, dx power. You want to differentiate this power. What do you get? You get n x n minus 1. This is what you get. So given that function here, you want to differentiate it. The product rule. If you are given two functions now, you have f of x, you have d dx, f of x times g of x. You have these two functions here, f of x and g of x. You want to multiply these two. At the same time, you want to differentiate them. So what do you get? You will have f of x times g prime of x plus g of x times f prime of x. That is, you differentiate one and the other one is constant, you add, then you differentiate the other one, then you keep the other one constant. When we do examples, you will soon see how these are done. Let's look at first problem. Problem number one. Problem number one says s equals, now I will use this space. Question number one. Question one says, find an expression for the velocity and the acceleration of a particle, given that the displacement is given by s this time. S is equals to 4t to the power of 4, 4t to the power of 4 minus 1 all over t. We are asked to find the displacement and acceleration of the displacement given for this particle. This is displacement is given as a function of time, 4t to the power of 4 minus 1 divided by t, and we're asked to find the velocity and acceleration. So what do we have here? We know velocity is what? What did we say about velocity? The s dt, that you differentiate this. So this will give us the s dt. That is, we are differentiating this function by dt. So what formula do we use? 4t to the power of 4. We have all these rules. The constant rule, the power rule, the product rule. We have more, two more. But these three are what we need for this level. That's why I didn't mention the fifth one. We don't need all four of them. We might need the quotient, the fourth one, but I haven't seen problems pertaining to the quotient rule in the book. So that's why I don't include it here. So now for this to the power, this has already a power here. So which rule do we use? There is a power rule here. This fine. We use this power rule formula. This is the one we use. This one here, you all know, 1 all over t, it can also be a power rule if we know that 1 all over t is the same as t raised to the power of minus 1. We know this. 1 all over t is the same as t to the power of minus 1. 1 all over 5 is the same as 5 to the power of minus 1. We know this. This way. So therefore, that is the case. This was still right. We use the power rule. The power rule says you have x to the n is equals to n. When you differentiate it, you get n x to the n minus 1. So what is n here? Our n here is 4. So already you have 4. There is a 4 already. So put it first. You are going to multiply it by. Now you have n. N is 4. Another 4 here. And what is left? You have now x. Our x here is t. N, our 4, minus 1. You finish with this first one. Minus. Now you have, there's just 1 here. ignore. But you have n, which is minus 1, again, minus 1. For this minus, this is our n here, it's minus 1, we put it. And then we'll have t, and then we'll have n, which is minus 1, minus 1 again, minus 1. So this is how we solve this. So what do you get? We have now 4 times 4, this is 16, t to the power of 4 minus 1, which is 3, minus 1, t to the power of minus 1, which is minus 2. So this is minus, this will give you plus. Yeah, minus, plus, minus. Minus times minus is plus. You are multiplying. So that is the displacement of the particle. 16 t to the power of 3 plus t to the power of minus 2. Let me just write it properly. Plus t to the power of minus 2. Or you can equally write it as 16 t to the power of 3 plus t plus 1 over t to the power of 2. And let's give the answer like that way. So now we are asked to find the acceleration of the particle. So let me remove this side. Let me just erase it. This one just explanation. These rules are the most important ones. The rules. Yeah. Okay. Now we've found the acceleration, the velocity of the particle. So now let's find the acceleration of this particle. We know velocity is the s, the t, and that is the s dt. We differentiate the displacement. Acceleration is the v, the t. We already stated this one earlier on, yeah? And we know v is the s dt. So you have d dt first for this. We are going to replace v by this. And now you have the s dt. And we did say that this will give you the square s dt square. That is the acceleration. So now we got the velocity here, which is given to us as velocity is equals to 16 t to the power of 3 plus 1 over t to the power of 2. We want to find the acceleration. Acceleration of this particle, I will say A, is the v dt, which is, we are differentiating now this function we have here, 16t cubed plus 1 over t squared. That's what we need to differentiate. So if you differentiate this is power. Again, use the power rule because it has a power function. Here, we use this rule. Most cases, you'll be using this rule. In most problems, this power rule is very important. So it's x, which is 3. We have 16 already. It's there. It's a constant. You leave it there. And x, which is 3, multiplies by 3. Then you have t to the 3 minus 1. That's the formula. Formula here. Plus this one, better you bring it up. So it's going to be like t minus 2. Yeah? T to the power of minus 2. So it's going to be t to the power of minus 2. So now, again, you have minus 2. Then t to the minus 2. And minus 1. Minus 1. So therefore, 16 times 3. This is 48. T, 3 minus 1 is 2. This is minus now, it's going to be minus t to the power of minus 3. Minus 2 minus 1 is minus 3. So this is the same as 48 t to the power of 2 minus t minus 1 all over t to the power of 3. That's the acceleration of this particle. Yeah? Thank you for watching.